go. So, last section in this unit involves solving a system of equations with three variables. So, there really isn't any difference between solving a system with two variables and solving a system with three variables. The only difference is that it's a little bit more work, because you have to have three different equations working. As far as methods go, you're still using either substitution or elimination. However, your final answer will be written as an ordered triple. So an ordered pair is two numbers, so an ordered triple is three numbers. Most of the time it's X, Y, and Z, or A, B, and C. But it can be whatever three letters are given. So you've seen systems with three equations and three variables a couple times on extra credit. I know that there was one on extra credit that from the quiz from last weekend. So now we'll actually go into how we go about solving these things. So we're going to start with a very basic one. When you have three equations and three variables, you want to get one. If you can get one answer, then you can start back solving. If you get one, then you can start plugging it in and working backwards. So example one. Find the solution of the system. We have 4x plus y plus 3x equals 14. 5y plus 2z equals -2. And z equals 4. So we have to figure out what x is equal to and what y is equal to. But the beautiful thing is that they already told us what z is equal to. So we've already got one answer. So now we start back solving. So we can take 4, plug it in for z. So we have two places where we can plug it in for z. 4x plus y plus 3 times 4 equals 14. So that's 4x plus y plus 12 equals 14. So other than that, I can't really do much with that right now. But 5y plus 2z equals -2. If I put in 4 for z, 5y plus 8 equals -2. That can be solved now. 5y equals -10, y equals -2. Now I have two answers. I know that z is equal to 4. I know that y is equal to -2. So now I can take -2 for y. -2 plus 12 is 10. 4x equals 4, x equals 1. So your answer, if we write this correctly, is 1, -2, 4. That's that problem. So, when they give you 1, it's very easy to start solving and get the rest. It's very easy to start solving and get the rest. Questions before we continue? That's the easy stuff. If they already give you one answer, that's the easy stuff. Now, when you have three legitimate equations, then you're going to have to use substitution or elimination. In that case, you need to condense three equations down to two equations. So we need to condense the equation so that we're only working with two variables. Ideally, we only want to work with two variables at a time. Three variables, now stuff starts to get a little hairy. So we're first going to do a problem with substitution. Then we'll do some with elimination. So, example 2. 2x minus 3y plus z equals 4. X minus 2z equals 1. Z equals negative y plus 2. Now, let me stress this in advance. There is no roadmap I can give you of how to start the problem, what to plug into. There is no one-size-fits-all, step-by-step procedure I can give you to solve it out. The only thing I can really tell you is that you need to look at the problem and see what you can reasonably do based off of what you know about the methods that you have. So if you think back to what we did earlier in this unit, substitution is when when a variable is already by itself, or when a variable can reasonably be gotten by itself. So notice you have z equals negative y plus 2. You have a variable already by itself. Cool. Take negative y plus 2, plug it into the second equation for z, plug it into the first equation for z, plug it in twice. Negative y plus 2 is 4, and x minus 2 times negative y plus 2 is 1. So of course you have a little bit of simplifying you need to do. First equation, you have 2x, negative 3, negative 1, negative 4, negative 4y, 2 plus 2 equals 4. So I'm going to take the 2 and move it over to the right-hand side. So subtract 2 on both sides. 2x minus 4y equals 2. So that's my rewritten first equation. Now I'm going to rewrite the second equation. Rewrite the second equation, distribute the negative 2, that's x plus 2y minus 4 equals 1. Take negative 4, move it over, so we can add 4 to both sides. X plus 2y equals 5. So now we've condensed it. We've taken the z variable out, and now we just have x and y left over. Any questions before we continue? I'm going to caution you in advance. The problem's going to take some work. This is not a problem you're about to finish in 30 seconds. If you're finishing in 30 seconds, you're probably using PhotoMath or some other computer program to do it. And good luck with that. That's a little nice. Do some work. Now we take our two equations. 2x minus 4y equals 2. X plus 2y equals 5. Now, just because we started with substitution, that doesn't mean we have to stay with substitution. We can use elimination whenever we want. So here, I'm about to use elimination. Why? Because 2 times 2 will give me 4. I'm multiplying the second equation by 2. Probably cancel out the y. Why? Felt like it. I see that I can use it. Yes?
What if I gave us to like 4, times 2 on the top and times 4 on the bottom?
You can if you want to. That's fine. So 2x minus 4y equals 2. 2x plus 4y equals 10. The y's drop out. 2x and 2x is 4x. 2 and 10 is 12. X equals 3. There's my first answer. Once you get one answer, everything else now pretty much takes care of itself. Take 3, put it in anywhere that it will work so that you can solve for something else. So I'm going to take 3. So it's not going to go there. That's a y. It's going to go right there. So x plus 2y equals 5. 3 plus 2y equals 5. 2y equals 2. Y equals 1. I've got 2 answers. So now I know that x is equal to y. X is equal to 3. Y is equal to 1. Now I'm going to get z. I've got 3 different places I can put this problem and get it solved. So I can pick whatever I want. I'm going to pick the third equation. Why? Felt like it. Take 1, plug it in for y. Z equals negative 1 plus 2. Z equals 1. So your answer is 3, 1, 1. So notice for this problem, we started with substitution, and then we used elimination. There will be problems in which you will be using both. If you can make it work, make it work. I could have just as easily used substitution for the entire problem. I could have made it work. But you have 2 methods to use for a reason. Use them. Any questions before we continue? Now, those of you who are looking for so first I do this, then I do this, or this is going to work all the time, or I always do it if this happens. then you're going to get pretty frustrated because I can't give you that for this. It's called look at the problem, figure out the way you should go. There's no roadmap I can give you. All I can tell you is that we did substitution and elimination for a reason. We did it with two variables so that you can use it with three variables. So all of our examples, we're going to be doing different examples in which we can use substitution and elimination. Ultimately, you're on your own to figure out how to make the problem work. Alright, so example 3. X minus y plus 2z equals negative 4. 3x plus y minus 4z equals negative 6. 2x plus 3z equals negative 1. So notice, this time, one of the variables, the y variable, wasn't present in the third equation. Okay, that's going to work. That's going to happen sometimes. So, he wants to take the two equations at the top and get rid of the y's. So if I'm looking at the two equations at the top, this looks so good. Amazingly good. Because they're already opposites. They're already sitting there as opposites. So we're about to do some elimination. We can do some elimination right off the bat. 3x plus y minus 4z equals negative 6. So those are opposites, they drop. 4x minus 2z equals negative 10. So now we've got a new equation. So 4x minus 2z equals negative 10. And you've got 2x plus 3z equals negative 1. Two x, thanks.
Is that 4Z?
4z.
Oh, wait, I guess it's not.
I just took the bottom equation and just moved it over because we didn't touch it. I see what you were saying though, so you're fine. So again, for some of the problems, if there's no roadmap I can give you, it's called figure it out. Your first step in your mind should be, I've got to get rid of one of these variables. One of them has to go. Figure out which one is the easiest to go, and work from there. Let's see, you talking about with our two new equations? Yes, we can do that.
Could you do 3 and then times 2, times 3, and then times 2 to cross out negative 6 and then positive 6 to do that?
So what letter are you trying to get rid of?
In the middle.
What letter are you trying to get rid of?
C.
You can do that. So, notice that there are two ways to approach this problem now. You can take the bottom equation, multiply it by negative 2. You can take the top, or you can take those two numbers and switch them and get rid of the z's. There's no one way to solve this problem. Being, your work is much more important now than ever, because I have to know what we did. I don't care what way, you need to show me what way you used. So, Since I heard this one first, that's the one I'm going to use. 4x minus 2z equals negative 10. Negative 4x minus 6z equals positive 2. So let's see what we got here. X's drop. Negative 2 plus negative 6 is negative 8. Negative 10 plus 2 is negative 8. So z equals 1. So there's our first answer. So since z is equal to 1, we have a couple of places that we can use to get x. So let's get our x value. So take z, plug it back in. 4 times x minus 2 times 1 is negative 10. 4x minus 2 equals negative 10. 4x equals negative 8. Equals negative 2. So now we need to get y. So y was only in 2 equations, the first one and the second one. So we need to pick one and make it work. 3x plus y minus 4z equals negative 6. Why did I choose the second one? Felt like it. X equals negative 2. Z equals 1. Plug in what you got. Negative 6 plus y minus 4 equals negative 6. Minus 10 equals negative 6. Y equals 4. So your answer is negative 2, comma 4, comma 1. That's it, problem's over. So, like I said, the problem in and of itself is not hard. They're just longer because there's more work you need to do. But it's not like you don't know how to do substitution or do elimination. Well, at least I'm going to find out when you take this, when I grade this quiz. But for some of you, you're going to need to take your time, have a little patience, and pay attention to what you are doing. Any questions on example 3? Notice with example 3, I never even touched, well, we never touched substitution. Didn't need to. You could theoretically solve every single one of these problems using elimination and never touch substitution. 3 variable systems, I will never tell you which way you gotta solve it. It's complex enough as it is, so let you figure that out yourself.